Welcome to Cyber Leaders with me, Ciaran Martin.
And me, James Lyne. Now, we're both from SANS who are kindly backing this podcast. I myself am a massive geek and I've spent my life chasing cyber criminals around the internet.
I'm not a techie, not good enough for that, but I dealt with cybersecurity policy and operations in government and set up the UK's National Cybersecurity Centre. But together, James and I are trying to unpack the weird, wacky, wireless and wired world of tech security and all the complicated things it involves.
I love that through the season we're going to add more W's, and by the end of it we'll be on to 17 W's. It's going to be the world's most impressive acronym. But anyway, this podcast is a voice for security leaders. We want CISOs, security directors and everyone beyond to build up their knowledge of what works, what doesn't, and ultimately secure their organizations more comprehensively and quickly.
What are you thinking about today, James?
I've been having a bit of an existential meta-crisis and the scale of the universe, properties of elements, and then I got myself thinking a little bit about the Feynman lectures and some of the limits of electrical engineering, and then I noticed there were daffodils outside, so I ended up there. Bit of an odd question, Ciaran, and what are you thinking about?
A bit of an odd answer if you want to go down that route, but I'm thinking about power stations and water plants and energy grids, chemical factories, blast furnaces, nuclear reactors, all the beautiful things in life, or at least, not like daffodils, at least the things that make life work.
Yeah, so maybe for the purposes of the podcast, you might want to think about cybersecurity potentially?
Oh, but I am thinking about cybersecurity.
Well, do go on, qualify more.
Yeah, well, we talk a lot about computer network security, about maintaining the software, the operating systems, and all of those things that allow us to spend our days merrily clicking away on all these devices. But even though we've talked on the show about all these menacing actors, the Russians with their attacks on Ukrainian power stations, the Chinese with the so-called Volt Typhoon threats against critical infrastructure, the ransomware criminals who take out things like pipelines in the US and hospitals everywhere, although we've talked about all that, we still haven't talked about protecting the critical systems.
Ah, yes. Excellent.
See?
I absolutely agree. We need to get to this. We can come back to the spring daffodils and nuclear reactors and which is more beautiful from a physics perspective. But anyway, on this topic, I think I've got just the guest.
I knew you would have just the guest, so go on then, introduce the guest.
So as you know, Ciaran, I'm the Chief Strategy Innovation Officer at SANS, and I've been around the SANS ecosystem for 14, 15, I've actually lost track of how many years.
Lots of years.
A long time. But I'm about to introduce one of our absolutely stellar instructors, the man of the living legend. This is Tim Conway. Now, he's the Technical Director for ICS and SCADA. Hold that thought, obviously pertinent, at SANS. But his background into the company is just fascinating. Before joining us, Tim spent 15 years at what he would call an owner asset operator, an OAO. Nice acronym, love that. More on that in a minute. It was at the gloriously named Northern Indiana Public Service Company, which I think sounds like something out of a Coen Brothers movie or a Steinbeck novel. So what does such a company do? Well, it's Indiana's largest natural gas distribution company, the second largest electric distribution company with nearly 1 million gas and 500,000 electricity customers in 32 counties. So he knows a thing or two about the big things that make life work, about scale and the challenges involved. He did all sorts of pioneering work in Indiana. He developed a passion, which you'll hear for yourself shortly, for the cyber protection of critical infrastructure, protecting those things with life and limb impact. And part of that passion was in training more people to protect it. So obviously he, talks to SANS. Turns out at that time we didn't have much in this space, as much as we should have given the developing importance of it. So Tim decides to write some of the most successful, popular, impactful and important SANS courses on industrial cyber security. He's also got some great stories, I have to admit. You must ask him about the illegal rave, but that's probably one for not on the podcast. He's written so much. He's been on so many expert advisory committees. He's won so many awards. He can't mention them all. My favorite, though, is that he's a faculty member at SANS, at the Technology Institute, our degree awarding college, which is, a National Security Agency Center of Excellence in cyber defense, I should add as well. So, look, I'm going to shut up. We should get to the Tim bit. We couldn't be happier to welcome Tim to the show for this fascinating topic, and I don't think we could have someone more qualified. Welcome, Tim.
Well, hello to both of you. And just to be clear, a nuclear facility is far more beautiful than a daffodil. just to be perfectly clear, there's no debate really.
I feel like Feynman would have agreed with you per the opening of my
Yes,
of my
course.
thinking there. But sorry, Ciaran, I'm getting in your way already. Look at that.
No, we're absolutely getting to the heart of it. A good bit of daffodil versus nuclear controversy is already there. I've got a picture of the beautiful industrial skyline of Gary, Indiana in my mind already. So, Tim, let me get a word in here after that brilliant introduction. So a few quick and easy questions to start with. So first of all, James's introduction, is it true or anything else you want to tell us about how you came to be in cybersecurity? What drove you?
Boy, that's a tough question. I've been asked that before and I've always struggled with an answer. I would say, as I've thought about it for a number of years through being asked, I would say it's largely unintentional, generally unplanned, and truly even today, as I get to be on this call with you and look to my left and right with the privilege of the people I get to work with every day inside of SANS, doing contracting, doing teaching, doing work for others, it's really unbelievable that I get to go into work every day and do what I really enjoy and love. But if you can believe it, I started in this industry about 28 years ago. And prior to that, I was an electrician and doing that work quite happily. But went off to electrical engineering school, and my professors there were protection relay engineers working for the utility, and got brought in there in the mid-90s. The biggest thing we had to worry about then was Y2K, and worked diligently along those projects and programs, and the rest is history.
Excellent. I love explaining to people younger than me about Y2K. We might come back to that.
That's a podcast episode bonus in of itself, isn't it? Probably a few t-shirts as well.
A few t-shirts, definitely, with 2 and 4 digits printed on them. Now, next up, simple question. Not all of our listeners, I'm genuinely happy to say this, not all of them are steeped in cybersecurity. And you are one of the small band of absolutely wonderful cybersecurity legends who came into it, in your own words, kind of accidentally. And maybe some of our listeners who aren't steeped in cybersecurity will do the same thing. So some people listen to this show because they live and breathe cybersecurity. Some have a general interest in the subject. I think some are subject to community orders by criminal judges and they have to listen to this as part of their punishment. Whatever. For those listening who aren't steeped in cybersecurity, simple question, what do the ICS and SCADA in your job title refer to?
Sure thing. So I'll answer that directly, and then I'll say it more broadly for those who aren't from the space. The acronym, just to be clear, Industrial Control Systems, so for the ICS side, and we pronounce it over in the States as SCADA. That would be Supervisory Control and Data Acquisition. But generally what that means from a SCADA perspective is the ability for an operator using a set of tools to send control commands to the field and get data back in regards to the state of the system. And all that to say, it's really kind of, if you look at information technology systems, largely data centric, and you look at operational technology systems, they have some type of physical or kinetic element or kinetic component to them. So you can broadly look at the term that is coming out from Gartner, that is cyber physical systems, is what is being represented by ICS and SCADA now.
Brilliant.
By the way, I always thought SCADA was a type of insect. We've officially got our first British versus American pronunciation issue.
Well, I was going to say, as well as the theme of t-shirts in this podcast, I think we're developing another theme around songs so we can adapt the famous one about I say SCADA, you say SCADA, etc., etc.
Oh, I like it. Or we could go for some EDM with... No, let's continue. Tim's going to be right on this one. It's his profession.
Yes, okay.
Cascada would be great.
We could introduce SCADA if we want to do a completely different...
Oh, SCADA. It's only SCADA when it gets hacked. You're truly SCADA'd.
Skadam.
Skadam.
Order, please. Order, as we say over here.
Order in the courtroom.
I'm broadcasting from near the Houses of Parliament, so I'm allowed to say that. So look, we've fallen out about nuclear facilities versus daffodils. We've fallen out about the pronunciation of a 5-letter acronym, which I'll go with SCADA for now, or SCADA. You've given us a really clear sense of what SCADA is and ICS, what they are. Why do they matter?
I think the easiest way to answer that is they matter for literally everything that you care about in your life, from turning on a switch in your home and the lights magically go on, to turning the burner on a stove and it lights and you have gas, to turning on a faucet and you have clean, fresh water that you can ingest straight into your body. But those are the things you touch and feel every day as you go out and interact with the world, kind of the goods and services through large port and maritime vessels, through ship-to-shore cranes, through rail, through traffic control systems, aviation, literally everything that we have, from food and agriculture, the big heavy machinery and manufacturing, they all have physical mechanical processes that we have chosen for very good reasons to automate. And because we've chosen to automate those things with digital components, we now sort of have this responsibility to ensure that those environments are cyber secure as well.
Well, Tim, just to follow up on that a little bit, can you give us a bit of a sense of the threat picture here? But for context, we've talked a lot on the show about making sure cyber defenders and everyone else has a realistic assessment of the threat. We've talked a little bit about hype. We even had a special episode on FUD, the legendary fear, uncertainty, and doubt. That was a fun one, wasn't it, Ciaran?
Sure was.
And as part of that, we talked about the sort of hype a decade or two ago about cyber attacks leading to the collapse of everything. Energy blackouts, ATMs not working, traffic lights going off, fires going off at power stations. We reminisced about, Ciaran and I meeting for the first time and the kind of London is falling-esque video playing behind him as we discussed kind of the ramifications of cybersecurity. And while there have been some very famous instances of this stuff, the attacks in these areas, we just know from reality in the news, it's not quite like that on an everyday or even yearly basis. But that doesn't mean it isn't important. It doesn't mean that it doesn't exist. We don't need to pay more attention to it in the future. So I guess in summary, what I'm asking you is, what's the real threat you're worried about here? Who does the threat come from? How worried should we be? Give us a bit of the landscape.
Supply chain attacks surged to 245% from 2023 to 2024. And breaches like the Oracle Cloud breach, GitHub Action supply chain compromise, and vulnerabilities such as Log4j have proven just how one compromised supplier can disrupt thousands of organizations. Whether you're looking for comprehensive training, expert-led webcast, or ready-to-use templates and frameworks, the new SANS Supply Chain Security Hub has everything you need to secure your supply chain, from development to deployment. Explore our resources at sans.org/supplychain.
I would say some of the threats for sure. One of the things that worries me is just becoming too passive on this topic. So kind of complacency is concerning if you're in critical infrastructure. So in general, if you look to kind of a high impact, low frequency event, sort of in the OT or the industrial control system space, it's the opposite of what we see in the news and what you hear every day from an IT cybersecurity perspective. So the high frequency, low impact events of credit card theft or kind of malware getting on a desktop in a 30,000 desktop corporate environment, kind of these high frequency occurring nonstop, noise in the system, low impact. The opposite of that, kind of in the OT and industrial control system or critical infrastructure space, is the very, very low frequency events that are occurring, but the extreme high impact that you can't afford to allow to happen. It's very easy to, when years would go by with tons of things happening in IT cybersecurity and nothing occurring in OT, to sort of start to move budgets and resources and personnel and training towards the things that were happening more frequently and less towards the things that were actually why your business existed. So if you think of the IT sides on how you manage your business, you look to the OT sides and you say, that's why we're a business. But now you look at how you're actually managing budgets and people and staff and resources, and they're definitely moving more towards what people see and hear all the time and less away from what can actually impact and destroy the business or a community or kind of an economic capability or national defense. So complacency is very, very worrisome. Beyond that, I think one piece that you would look to is the differences now between the haves and the have-nots. So if you were looking at an electric utility or a water treatment facility, for example, and you were looking at a very, very large utility, they likely understand these risks and they have resources to manage it and do something about it. Very, very small do not. And from an adversary group, being able to go into these interconnected systems and cause cascading outages from the very, very small and kind of the weakest link is a very real potential. So that is also concerning to me, is the differences between the haves and have-nots, which you don't just see at business size, but you also see between countries and nations. So the countries and nations that have focused programs and government-supported resources for the small entities, you go to other countries where that just doesn't exist, even at the big organizations in those nations.
Yeah, that makes a lot of sense, Tim. I too worry about the complacency aspect, and it's particularly difficult in an area here where it ought to be so natural to think of the risks and care. This is an area where there truly is that life and limb impact from these things going wrong, but calibrating between these kind of cataclysmic FUD scenarios and, it's probably okay, it does seem to be rather tricky for this part of the industry and our broader community as well.
And James, I would say that's not just from a cyber risk perspective. If you think about, having worked in this space for 28 some years, it is something I've seen in just about every sector I've been in from a critical infrastructure side, even all of us on the phone. And I've worked in this space for a long time. You think about your utility twice in your general life. When it's down, and you have no power, or you have no gas, or you have no water, or when you're paying your bill. And that's it. Generally, you're not thinking about it consciously in your normal daily life.
Yeah, that's right. It's just there and taken for granted, isn't it?
Yes. As things happen like wildfire, so sort of drought and no rain and high wind conditions, and the transmission operator is trying to keep the system up. And because of that sparking event, it causes a wildfire and an entire community burns. That's when you sort of look to the utilities that have been impacted by that in parts of the world. And they have been trained for their entire existence to keep power up all the time. And now they're being trained. You honestly need to think about that differently and potentially creating outages or line clearances because of weather conditions. We're honestly at a point where we need to start operating in a similar way with cyber. Meaning, if we know our system is completely compromised, would we continue to keep it up for someone else to misoperate it and cause harm?
Yeah, and then Tim, I like to test something with you, those kind of remarks you've made there, and I certainly agree with you with it being a broader issue. I've heard a few times this notion that this kind of area of industrial control and SCADA, see, I got it right that time, is
well done.
kind of 15 to 20 years behind the mainstream computing environment in terms of the levels of the controls. And I've had some discussion that applies at every level. So the clinging on to perimeter stuff, if you look at the kind of modern Microsoft operating system, it's been bombarded by exploits and malware and been forced to introduce many new controls. Whereas a lot of the stuff we're talking about here, to your point, has sat in the background and operated. It's done its thing in a corner, hasn't been under that same pressure. And so a lot of it is just so far behind the mainstream computing environment in terms of its potential vulnerability if it ends up exposed. Is that a hypey statement? Is it broadly supportable? How do you think about that?
Can I just jump in? Is it like the famous cartoon that many in the cybersecurity community know of, the industrial control system with that little bit that's propping everything else up that somebody in Nevada you've never heard of has been maintaining for the last 20 years? Is that true?
Under a desk.
So I would say all of the things that you've heard and seen, there's truth in them all. But the most important piece when you're talking about critical infrastructure that I would like to get in everybody's head that's listening here today, and I know both of you gentlemen, and I'm sure are aware, but this is a sector and kind of an industry that you cannot paint with one brush. You can't say the electric sector or the nuclear sector or rail or water or aviation is 30 years behind or 20 years behind. It really, really varies. And it varies by sector, by geography, by size of company. For example, out of the electric utility side, on control centers, they're very, very innovative, current emerging technology with full capabilities, in some cases beyond what you would find in a lot of corporate environments that are cybersecurity focused, because they know the impact, the wide area impact if their system is compromised. If you move down to a generating station where they're trying to squeeze every penny out of the system for every megawatt that they create, you will find some older legacy systems, but in some parts of the world, they've been heavily regulated. And to comply with those cybersecurity requirements, they had to have upgraded over time. So we were doing controls packages and control system upgrades constantly. If you move into transmission substation, no one ever wants to take line clearances. No one ever wants to ever cause an outage. It's why they're flying helicopters with line patrol workers and line workers, and they're strapping onto the lines while they're energized because they're not taking them down. So they're certainly not going to go take down assets to patch them unless they can get line clearances, and they have to. So sort of how you manage and maintain across even that sector is very different than the same things you would do in energy at a nuclear facility, or very same of what you would do in renewables or in wind or in offshore wind at sea, where you'd have to take a helicopter out to a platform to patch a Windows asset. So even just in the sector of energy, wide variations of what part and where, and then what size company. And now if you look to rail and you look to aviation and kind of all of those things, or space, you have very different timing. So just sort of some understanding around, you can't paint it all with one brush. Can you find 30, 40-year-old assets? Of course you can. Can you find entire control system environments that are newer than some banking and finance sectors? Absolutely. Large variations.
So Tim, this is already fascinating. And just to go back to something you said earlier, really struck by this differentiation between high impact, low frequency events that you worry about and the high frequency, low impact events that sometimes dominate cybersecurity. And I think sort of leads to a different type of complacency. We get complacent about data breaches because they happen all the time, but some of the impact of them is pretty low. I guess in risk management terms, your threats and risks are much more, they're almost like pandemics or acts of terrorism. They are massive, but sometimes if they don't happen for a long time, you can forget about them. So to that end, I was going to ask you just to bring it to life a bit in terms of impact. So is there a standout case that you can think of to illustrate this? It may even be an anonymized near miss. It could be something coming out of Ukraine in the war. It could be Colonial Pipeline, even Stuxnet, obviously an operation against adversaries rather than by them. But how would you illustrate what can happen in operational technology and industrial control system risk?
I think I'm going to spend a little bit more time on this just from the perspective of there's so often the concern that I have on complacency when you go to an asset owner, an operator, or to a critical infrastructure, some in leadership, some kind of on the IT side, or even on the operations and process side. They sort of lead with, do we need to actually have a focus on this from an overall risk perspective? Because are events actually happening? Is anything happening? Give me some examples. And that is a very common type of discussion and sort of reason to not pursue. So I'll give you a couple. I'll give you one that is kind of an example towards impacting operations without directly targeting it. And that example being kind of Colonial Pipeline. So nothing from a compressor station, pumping station, terminal station, SCADA system, industrial control side was impacted. The system that is sort of in between IT and OT that's tracking products on a shared common pipeline and pushing those multiple products and multiple customer products down that pipeline is tracking where the jet fuel is, where the home heating oil is, where the diesel fuel is. And when that system is impacted, while you can continue to operate the pipeline, you would choose not to for safety because you don't want to put home heating oil in a jet and you don't want to put jet fuel in your car. So the need for assurance and integrity on that system, you didn't have to compromise the industrial control or SCADA system to cause an operational outage. If we wanted to go impact a pharmaceutical plant, for example, it could be very difficult for us to get into the control side and the batching and dosing of that plant because of security controls and limitations. But we could impact all the product leaving it by changing the printing and the labeling. So there will be product recalls, there will be impacts, but we caused a massive operational impact, but we didn't have to get to operations. Moving beyond that, I think just looking at other examples, you mentioned Ukraine, kind of everybody in the world has seen and heard of Stuxnet. Those two things, as you start to look at those and see operators can achieve, meaning adversarial operators, can achieve certain capabilities and effects by misoperating the system as it was designed and engineered, just using it in ways it was never intended. And the only thing preventing them from doing that is access. So the vulnerability that matters here is access.
Yeah.
Moving down the path of being able to build something that now spreads across and kind of demonstrating capabilities to attack at scale. And most recently, throughout the invasion in Ukraine, kind of demonstrated capability to develop unique modular malware for industrial control systems where you could customize it at speed. Those sort of 4 lessons learned or case study examples, there's a lot to learn across every sector and every environment, but those 4 are really applicable to all critical infrastructure everywhere globally.
So there's so much in what you just said. I'm going to try and bring out one thing because it made such an impact on me and you've brought it out, which was Colonial Pipeline. I remember when I was in government issuing all sorts of guidance to critical infrastructure operators at the National Cybersecurity Centre, we were always talking about air gaps between enterprise technology and operational technology. And then Colonial, as you brilliantly brought out, didn't touch the operational technology in the sense that we might traditionally have talked about it. And I think that's such an important point about the holistic nature of the security. And I think James wants to pick up on that as he takes us on in the conversation.
Yeah. Well, I mean, one must, right? And let's go to more recent examples here. Look, we've talked with other guests about the so-called Volt Typhoon threat, right? A Chinese military operation to pre-position disruptive implants all over American critical infrastructure for use in the event of a geopolitical crisis. Or at least that's what it looks like. Maybe they were just having fun. But what did you think when you first heard about Volt Typhoon? And now that more details have come to the fore and things have moved on, what do you think now, Tim?
I'm not going to say I wasn't surprised, as some kind of in this sector might come out and say, yep, we've been saying it's not a matter of if, it's a matter of when. I don't want to sound as sort of predictive as all that, but I would tell you, as you look to the Salt Typhoon and you look to all the information collection campaigns and even kind of the ransomware, information theft, all the things happening, fog of war that are occurring around the globe all the time, as you start to move beyond information collection campaigns and you're looking at access operations, and then you start to see pre-positioning. And that pre-positioning is not only concerning from the perspective of where and what types of asset owners, what types of operators, what types of sectors. Is it something that's being done from a competitive nature, from industry to industry? Is it something being done at a large scale from a military perspective? But when you look to a lot of what was being identified and released in regards to Volt Typhoon, it's definitely leaning towards, as was provided in the testimony from a lot of our national defense, our intelligence, and experts across our government, it's in many cases looking towards societal chaos. It's in a lot of places in smaller entities and smaller utilities that would have no staff to really detect, not a lot of training or resources on the defense. The potential for broad impacts across many service areas. So very concerning from that nature. But beyond that, kind of leaning in and saying, if we all put on our, hey, let's pretend to be offensive targeters for a country. And let's say that's what we did for our living. As you look at sort of the tradecraft and what we do and when we do it, that pre-positioning piece in those networks, that starts the clock on how long do you live there before you're detected and what can you do in there and how frequently do you have to validate capabilities. Usually that would be closer to when it was intended to be used. So there's a signaling here that's either the perception of time is getting closer or there's a completely second 4D chess model being played of overtly positioning so it acts as a deterrent. So either way, it's a concerning introduction of what we're facing now as a reality.
So at the risk of draining away any of the optimism that we sometimes try to generate in this podcast about cybersecurity.
Well, you do. I usually sap it away, but that's why we're a good balance, isn't it?
Well, not today. Wait for the next question. One of the things that I used to find reassuring, maybe you would disagree, Tim, about the risk to the big operational technology systems was that hacking them properly seemed to be quite hard. You looked at some of the Russian operations in Ukraine back in the last decade, the Indestroyer, the Black Energy, for those who don't know, big operations against power plants and energy infrastructure and so forth. And they seemed quite hard to do. They seemed to take a long time. They seemed to use a lot of resource. So actually that inability to scale was one of the sort of militating factors in the defender's favor. Is that changing? Does Volt Typhoon tell us something different about that? Or was I just wrong in the first place?
I think you're not wrong, meaning depending on what the adversary goal is, it can be very hard. If your goal is to have the ability to attack and cause outages, that may be not as hard as you think, depending on the particular target that you chose, if it's a target of selection or a target of opportunity. Being able to re-attack and have successful operations over and over again, that gets harder, obviously. Being able to do that without burning any of your capabilities, that gets harder. Being able to do an attack specifically and cause destruction of the equipment or cause destruction of load or cause destruction of an environment, that gets even harder because now you need to understand sort of the engineering and the operations and the safety controls and components in place. So depending on the goal and the objective, in some cases you could say this is harder. If the goal is to simply connect once and cause an outage, that's definitely leaning more towards the easier side. So it often depends. If you're looking towards the Ukraine 2015 event, that's kind of an approach where what was conducted and what was done without burning a tremendous amount of capability, but causing over 50 different substation outages, 225,000 customers out. And that was just the beginning of the attack. The outage was the beginning, then moving down the path of destroying data, destroying voice and communications to the field, impacting uninterruptible power supplies, and all of those things orchestrated together. That concept of operations, was fairly advanced, considering the only piece of malware that was burned was one remote access Trojan. That's it. It's a Black Energy 3.
Pretty low cost approach.
So the way it was conducted was fairly advanced.
Very efficient.
Of course. Now, if you move into Trisis, Triton, or Hatman, now you're in a very advanced attack, looking at safety instrumented systems, understanding the engineering and the process under control. So then you could achieve a result. Now it's getting more advanced and more difficult to achieve.
Yeah, no, it is going to be interesting to watch how this stuff evolves. I mean, you talk there about what seem like some relatively conflicting statements of the high technical competence of some of these attacks, and also the efficiency and low costs of some of these attacks, kind of asymmetric benefit to what they may then enable because of the nature of these systems. But I suppose kind of following into that, I want to ask you two important questions, both beginning with R. It's a nice soft R as well, not a rolling royal one. Resilience and regulation. So look, we live in a country where, or at least Ciaran and I do, this year, although not cyber related, a fire in one substation closed down what is by far the country's most important airport for a full day. You live in a country where a ransomware attack shuts off a pipeline and has a huge impact. Since COVID, people all over the world have been talking about resilience. Is it realistic to demand better, or is it just too expensive? I mean, are we kind of asking for better, but having to admit that it would cost just too much money to actually make these changes? We just need to suck up these problems. Does the law have a role to play? How do you think about resilience and regulation?
So definitely the way our countries look at regulation differs. So I'll hold on that one for a second. But on the resilience piece, that is something that from an overall risk, and it really, again, kind of looking at the process that's under control. So if you're manufacturing a component for an automobile, a car door or a hood, you may have different risk tolerance for resilience on a line going down and what that impacts you from a revenue perspective. You may have a different expectation of resilience if you're in the healthcare industry and building management, air handling, essential service power, patient care systems. You may have a different tolerance for resilience in those going down when they're directly tied to human life. And then you may look at things like electric power that are part of a large scale system or natural gas pipeline delivery or water, where again, resilience, you have different tolerances of. So electric power failures, speed of light, and cascades as such. So you need to consider what happens if it's unavailable. On a natural gas, you have a pressurized system and what is being consumed on the other end from home heating oil. But as we've converted a lot of power generation to natural gas fed, now you consider an attack on natural gas as an attack on power generation. So you have a different risk tolerance now that you're starting to flavor in that sector. When you look to water and you say, if something is wrong with the water, it's on a radio line to certain customers in certain communities. And frankly, we could issue a boil order and have people not consume, and appropriate warnings and emergency systems where we could go and address the matter. So each sector has variations here. The reference to the airport and substation event, you look to some of these high power transformers, they live 60 years. So to the degree of should we have 2 or 3 or 4 in spares, and how quickly could we move them in, and what are the impacts? Or if it's unavailable, how do we operate around it and ensure that you have the appropriate switching and the appropriate redundancies if you can't afford to have that outage? To some degree, it comes down to money, as you mentioned. So the asset owner and operator, they're going to make those risk decisions and they're going to decide. To some degree, it comes to the regulation of the customers, the residences, the communities that you serve. They come forward and say the duration of the outages have been too long. The frequency of the outages has been too long or too frequent. Therefore, we don't want to pay more in rates. We don't want to pay more in taxes. And the companies will pay in penalties or in fines or impacts to how they operate or their ability to operate over a certain area. So sort of when it's feeding that community side, it comes forward. And I think that is a piece that is somewhat different in regards to critical infrastructure, where the operators themselves, they live and work in the communities they serve. So they know the failures. If something isn't done appropriately, they feel it, their families feel it, others do as well.
So Tim, a quick follow-up. I kind of mentioned this kind of since COVID or post-COVID that seems to have kind of been a point in the industry where a lot of thinking about a lot of priorities have changed. As I mentioned, we've been talking a lot about supply chain resilience. How much do you think the hardware matters in the cybersecurity posture of an OT organization? Should companies be looking more carefully at where their hardware comes from and how it's built? Or is this predominantly a software and defenses and processes and people thing? I mean, I know it's all of them, but what about the hardware?
We are definitely still a hardware-focused sector. When you come to industrial control systems, you sort of get a different blend when people are talking about OT and automation. And then certainly on the IIoT or the IoT, you end up getting wild variations. But largely, if you're looking at process and you're looking at industrial control systems and critical infrastructure, there's still inputs and outputs in the field that are connected to sensors and actuators that are going back to controllers. So that the hardware devices and the hardware elements are very, very important. How they communicate all the way back. And then you enter into the software layer of the very specific ICS and OT applications. All of those things, kind of the ICS and OT applications, now very commonly are running on traditional corporate business enterprise level desktops, similar kind of common server environments. Many of them have moved to cloud-based and virtual. But in the plant or in the field, you still have the physical controllers and the physical components talking to the direct input-output kind of sensors and actuators. So that was my long way of getting to a point of the hardware devices matter. But it's not just the PLCs. There's just as much concern in this sector as there is in the motherboards and the video cards and the network switching and infrastructure devices that are coming, and the concerns in supply chain for those hardware devices that the IT side faces in the traditional IT industry. So it's not just the controllers, it's not just the sensors and the actuators and the controlled elements, but it's also where we're running our applications and software devices. And it's kind of across sectors where this is tried to be pursued. In no manner has anybody gotten to a point where they felt like we've solved the supply chain problem. Everywhere where it's sort of been kind of addressed to some degree, it's acknowledged that we have begun addressing it with things like we have seen supply chain attacks going after where we get our support and maintenance updates and through vendor portals. So regulation has been made to make sure we're doing what we should be doing to verify the authenticity and integrity of software products and downloads and support and maintenance after we've taken lifecycle upgrades of that commissioned system. We've looked to third-party risk and remote access and the events that have happened over time that have led us down the path of this is a risk we have to deal with and kind of managing those components specifically in supply chain. And ultimately, the need for vendors and providers in this space, because we don't make the hardware elements, the controllers, and the software packages. We rely on who we marry from the original equipment manufacturers and what vendors and what products we're using. So mandatory kind of procurement requirements for breach notification and alternate needs of operating during a breach and throughout a breach until a resolution. So the things that we've seen already affect industrial control systems and critical infrastructure, that's what we've tried to start introducing and addressing into supply chain regulation and procurement and finding better ways. There's a massive, massive pile of things that we haven't even begun that you're really hearing about in the IT space just as much as you're hearing about in the OT space on software bill of materials and hardware bill of materials and validation of code snippets and middleware. And all of those things are not unique to either IT or OT. They're present in both. And at no stretch do we feel like, oh, well, we have a supply chain standard and a supply chain regulation. Does anyone believe that we've solved the supply chain problem?
It sounds like, Tim, you're saying we have a lot of work to do, far from mission accomplished, but there's almost a twang of positivity in the progress we have made using the likes of regulations as a tool. Is that the kind of right balance from how you're describing it, or did I kind of over-listen to your remarks, hoping for some positivity in place of Ciaran's negativity today?
I was very much on the side of, while all industries, while all sectors were marching forward for a couple of decades and sort of identifying guidelines and identifying recommendations and sort of seeing that live its life where no one's pursuing it until they have to, kind of a model. So as much as I was against regulations, when I started to see them come in and force action and force behaviors and force additional resources, but then also start to see what that meant. So one sector coming in with regulations that started having demands for authentication and authorization and security hardening and all the things we've been talking about forever, now it's regulated. And then the occurrence to me that, hey, what we're going to our vendors and mandating as product support and capability, all the other sectors use those same vendors. So regulating to this one starts to have this umbrella and cascading approach across all of the others who are using the same products and the same companies. And I started to see the benefits beyond just this one sector in this one part of the world. And then as we started to see, hey, you have to have this type of capability, and that means you need additional staffing and additional tools and technology. And now you get all these other benefits for other parts of your organization. I started to become a believer in what I will say is good, mature regulation. The piece where I still have some concerns is where I'm seeing regulation emerge, and it's not trying to gain any lessons learned from the 2 decades of regulation that has existed in other sectors. It's starting from this perspective of, well, we're in rail, so we're a unique snowflake and nobody's ever done this before. We're going to go create our own. Or we're in water, so we're going to go create our own. We're in energy, we're going to go create our own. Where there's a ton.
A little bit of not invented here syndrome, is there?
Yes, there's a ton that we could all be learning from each other and looking to existing regulation, existing requirements, and how you enforce it. There's a lot to learn, and it shouldn't be ignored.
No, that makes a lot of sense. I mean, ignoring lessons of the past and reinventing the wheel every time are things we all roll our eyes at, and yet tragically frequently in this domain seem to be things we go and do. So anyway, sorry, Ciaran, over to you.
Well, I think you may have mentioned this a bit in an earlier question, but I wanted to ask you specifically on regulation of critical infrastructure. Europe and America quite clearly are taking 2 quite distinct approaches. Europe's regulating quite heavily for cybersecurity and critical infrastructure with NIS2, the Network Information Systems Directive version 2. The US basically isn't. Do you have a view on which is right?
So I'll say if you sort of create a perfect world, you would say what is happening with NIST-2 more correct. Just from this first statement that I'll say, the US tends to wait for some big bad thing to happen. Some big bad thing happens, so we come in with NEI 0809 for nuclear cybersecurity regulations. Some big bad thing happens. We have an August 14th, 2003 blackout impacting the Northeast, trillions in economic impact. We go and create NERC-CIP and the cybersecurity regulations for the electric sector. Colonial Pipeline happens. We pursue security directives. We are looking to things that are occurring since October 7th across water sector. We're considering cybersecurity for water. So that sounds wrong. That sounds we're reactive and only reactive. And we're ignoring other sectors that we know we're just waiting for their event and waiting for the impact, and then we'll start. What Europe is doing with this too sounds more appropriate, where all 27 EU member countries are going to go identify their critical and essential entities, and they're going to start implementing requirements before the big bad thing happens. So you want to say what NIST-2 is doing is more right because it feels more right. It's proactively going after something before the big bad event. The piece that I would say where you start to look at the realities of this, when the big bad thing happens in the US, it's a call to action. And there's budgets and there's resources, and the asset owners and operators and leadership all understand the why behind what they're doing in a sector.
It's based on tangible data, isn't it? It's not hypothetical. It's a real crisp example.
And the citizens understand it, meaning they know why they're seeing increases in regulatory type costs for that one sector. And that's where you're seeing it happening, and then it grows and it matures and it becomes a bigger, better thing. When you look to what's happening over in NIST-2, the realities of this, doing 27 member countries all at once, all sectors across them all, with 20,000 entities in one country and 40,000 entities in another country, and looking at the workforce demands alone of doing it all at once and sort of trying to hit every sector, every country, all at the same time, what that's going to mean and how successful is it going to be. And frankly, what they could even write into legislation to require may not be as effective as what we've lived over in the States, doing it kind of one sector at a time, reacting to when the big bad thing happens. Only time will tell. I don't know that any of us know the right way or the wrong way.
That makes a lot of sense. But that's an articulate description of the differences in approach. And I could definitely see the merits of both. And I can see why it feels better to take that European approach as well. But I love the, action based on tangible examples people can understand. So it doesn't feel like regulation for regulation's sake, where people roll their eyes. I suppose in reality, it'd be lovely if we could be halfway between Europe and America, which I think is somewhere in Greenland or like Halifax, Canada, or in the ocean somewhat. So somewhere around there. I have to look that up after. But look, finally, Tim, and not briefly, take your time, unless you can solve it in one sentence, in which case that's wonderful, because this is really important. Tell us about the key aspects of defending this space, this stuff, and the threats we're talking about it. I mean, I know I'm asking you to generalize and silver bullet all these attack vectors and all these different types of equipment, but how do you do it? What is the best practice? And I suppose, how is it just different from enterprise cybersecurity for those of us that are used to worrying about desktops and servers and kind of mainstream computing environments?
I would say, to that degree, one of the most unique pieces that really makes me love what I do, and every day is unique, is every process, everything that they're doing starts with, there's a business, there's a product or a solution that they provide, and there's just kind of the big machines that they use to do it. And because of that process being unique, the how they automate it, how they control it, how they digitize it, and then how you need to cyber secure it is very unique everywhere you go. So from a how do you do it, there's not one right answer, even for a sector, for a set of facilities. And there's not even kind of this approach of, well, I've been doing this for X number of years, so I'm an industrial control system subject matter expert. Those don't really exist. You kind of go into a facility and you say, tell me about what you do here, and then tell me how you do it. And now we can talk about, based on what you do and how you do it, how we need to now defend it and secure it and support it to ensure operations and safety and reliability all function. And then the next facility you go to, or even the next line at that same facility, or the next generator at that same generation company, or a neighboring facility, you get to start over and ask the same questions, learn the same things and learn different things, and then apply uniquely how are you going to secure and defend. To the degree that we've seen commonalities, again, this is something that we look to kind of in your second and third grade, and some countries, maybe your first grade learning. When you look up at the periodic table of elements and you kind of learn all the different things that make up our world, we sort of look to that and say, what are the different controls? What are our atomic elements that we can sort of build and support a process with? And then what things can we use to sort of stick together and secure those environments? And as we sort of see commonalities across different environments, and then from an incident response perspective, we see commonalities in what attackers are doing and what adversaries are doing. So from a threat informed perspective, we can do things like at SANS where we say, here's the top 5 industrial control system critical controls. If you're doing nothing and you're looking for a place to start and you have no resources and you're not going to bring in consultants and you're not going to bring in contractors and security experts, at least pursue these 5 things. If you're an organization that's beyond these, or you have regulations and you have the resources to pursue, absolutely go special tune, kind of fine tune what's right for your environment. But if you have nothing, we could sort of look to the common components and we could look to the common attack approaches and point to, here's 5 things, like what started with the SANS Top 20 and moved to the CIS 18. We sort of made a version of that was for critical infrastructure and industrial control systems because of the things that keep us up at night, the small entities that lack resources. We wanted to make sure we took what we've seen and tried to provide what you should go pursue.
That makes a lot of sense. And as much as I gave you the impossible task of summarizing the entire space, I think you did it aptly. Although I know our producer is going to be furrowed in her brow, kind of worrying about the show notes on this with the number of different attacks, best practices, standards, and resources you have mentioned. This is going to be linkerific, this one. It's going to be basically like Ulysses, but hyperlinks. But anyway, look, Tim, one last thing, and then I'm going to let you get back to saving all this important infrastructure. We've covered so much, but there is something we love to do at the end of every show. We think it's only fair if people listen to us, we give them something really crisp and useful at the end. So we do a 30-second takeaway. It doesn't have to be precisely 30 seconds, although if you'd like to challenge yourself to hitting it on the nose, you're welcome to. But this podcast is about lessons for cybersecurity leaders. So if you had just 30 seconds with a leader, could be one of these new OT-focused CISOs, it could be an enterprise CISO, could be anyone you pick here, or the whole industry. What would you advise them about the best things they can do to protect these key systems on which we all depend? Something to start doing, stop doing, or pay attention to. Anything you like, 30 seconds, solve world peace, go.
I would highlight and ask leaders to sort of recognize the importance of OT systems and ICS and why they're a business. So if they're in the world of kind of making something, moving something, powering something, if they're in that space, understand that OT and ICS systems are why they are a business. And then I would look to the humans and ensure that you're doing everything in your power, in your term of office to enable and equip those people.
Amazing, Tim. Thank you. Informative, really useful, and remarkably concise.
I like it. And it actually fitted in the 30 seconds. Is there anything you can't do? I suspect it's probably growing daffodils, actually. That's probably a challenge. I bet you don't have green fingers if you prefer nuclear reactors. But hey, Tim, we're going to let you go there because I know this has been a long episode. But Ciaran and I couldn't help ourselves because you have so much to share. It's just a fascinating space and it's going to be of growing importance. I mean, we're going to depend on more of this technology and its temptation for adversaries is only going to increase in the world ahead. So really proud to have you at SANS and doing this type of work in the community as well. Thanks for sharing some time with us today. And I hope you'll come and update us on all of this very soon when European regulations take over the entire world.
Absolutely, James. Thank you so much, Tim.
Of course. It's been my pleasure. Thanks for having me.
Absolute pleasure. See you soon, Tim. Thank you. Well, excellent. I guess that's it, Ciaran.
Apart from feedback, James?
Yes, that's it. Feedback, always important.
You can leave us feedback at the podcast site, or you can email us at cyberleaderspodcast@sans.org. Tell us what you'd like to hear more, less of, or anything you like.
And with that, thank you all for listening.
Yes, thank you for listening and keep cybering. So for me, Ciaran Martin.
And me, James Line.
It's goodbye.
Or kill -9.